Hello. Today for my final project, I'll be talking about human evolution, specifically with regard to the environment and climate. There's a new article that I came across that discusses this, and then I'll also go into further just general human evolution stuff, and also talk about a pretty cool subject called evolutionary medicine. So the article that I came across was called "Turbulent Environment Set the Stage for Leaps in Human Evolution and Technology 320,000 Years Ago." So this researcher in Kenya used geology to just learn about the different environments before and after this, kind of when you see these two types of tool making in early humans. And it basically showed before this time and after there was more of a stable environment where food was plentiful, rainfall was predictable, and then it kind of diverged into a very unstable and uncertain environment um, where these food sources weren't like large ungulates and things like that were not as readily available. Rainfall was not predictable, so just an overall uncertain environment. And this type of environment, this change drove innovation in early humans. So it actually helped. It basically pushed us to make changes. And what they see in the difference in tool making is, when in regard to like arrowheads, is that you see a finer, more precise, than and smaller, more just better overall, more advanced looking tools that arise from this. And the other factor that this talks about is adaptable diets as well. So, being able to, not be dependent on one type of food, it's an important factor in reproductive success. And we've seen this with other animals like coyotes and things like that. If you're just eating one thing and that thing goes like monoculturing, if that thing goes bad, then you're going to be in a bad way. So early on with human evolution, it wasn't really widely accepted. Darwin actually himself chose to keep away from the topic. He didn't really want to touch it. But however, this was implicit in his theory. So we were lumped in with hominids. You know, he he included us without specifically saying us, because he wanted to not go near it. So if you look at the image to the right, that's actually from like just a newspaper or cartoonist. So even despite the fact that he tried to avoid it, it still kind of got tied up in with him, um, and still resulted in kind of some mockery from the other side. And early human evolution, scientists just had a hard time accepting it during that time in 19th century. They couldn't accept that we were related to primates, because the ones that were alive we were so different from, and they didn't understand genetics and DNA, so they didn't have genomics, so they couldn't see the actual relatedness via the genetic information. Humans were kind of held separate or apart from animals in the animal kingdom. We were kind of the chosen species, it kind of not separate. We were held above. And also at the time, the fossil record was really poor, so physical evidence was lacking. We didn't really have that stuff, those missing pieces, those links, those different hominid human species, like Lucy and stuff like that. So, as future went on and we were able to find those things, the stuff got a little better. So, what are the current perspectives on human evolution? Well, currently, I mean, obviously we accept that humans are evolving, and there is actually some evidence of this in different things. They've seen mutations in people that live on or near the sea for diving. In the Philippines, they've seen people that live in in the high elevations that have mutations to be able to survive up there a little bit better. And then they also have a new one in the forearm, that there's a median blood vessel in your forearm that most people absorb it, or it fuses back together after maturation. But we're starting to see people keep these for whatever reason. So there is evidence of it going on. Fossils are being discovered all the time, and so we're seeing missing pieces being put together, and new family members and ancestors being present, and we're just learning more and adjusting our theories as we go. We also have the benefit of genome sequencing. So we have sequenced the entire human genome and the Neanderthal for that. So, and we've actually found that we actually bred with Neanderthals. There's people in society nowadays that actually have some Neanderthal DNA inside them. So they may be extinct as a species, but they do actually live on in us. So that's pretty interesting. And then one of the things that the article talked about, and what we're seeing kind of when you read through the literature, is that climate is a primary driving force for human evolution. And this makes sense because if you're living in a certain climate, you've got to be able to adapt. You've got to be able to prepare. When things are good and things are plentiful and nothing's changing, then it's probably not going to be a lot of evolution. And also, anytime things become sparse or restricted or limited, then you have to fight for those resources, and all those things are going to create differentials or variability in reproductive success. And so that's going to really be a driving force for evolution, not just for human beings, but for any animal. And with our current situation with climate change, I mean, it's curious to see what this effect will have on our society. Is it going to destroy us, or is it going to push us to much higher levels of advancement and much higher levels of basically spark a golden age or a renaissance in research and discovery? And then what's our next stage of evolution? This is an interesting topic that a lot of futurists and people talk about, but, with emerging technologies like nanotechnology, nanobots, CRISPR, I mean, we're going to see things being fused together and melded together and editing on a level that we've never seen before, selective breeding on a level we've never seen before. And so it's curious to see how this is going to go, and ultimately, how we're going to change, like how is it going to change to be human over time. So the last thing I really wanted to talk about was just a subject that's very close and personal to me, as I really enjoy, is evolutionary medicine. It's a very exciting field, and it's actually, there's a class at ASU that teaches about it, and we actually have an ASU Center for Evolution and Medicine. I believe it's the first one in the country, and it's graduate and undergraduate certificates as well. So check that. I put the link on there if you guys are interested. So it's basically approaching medicine from an evolutionary perspective. So it looks at evolutionary relationships between us and pathogens. That's a small thing. There's other areas of it too, but just trying to approach treatment of disease and treatment of illness from a way that, when it comes to specifically a pathogen, a lot of them outside of new, novel and emerging viruses or bacteria, most of these things we've evolved for a long time, so we have a relationship with them. And sometimes, removing these pathogens can have effects on our immune system and all kinds of things. So, and also with what effect climate change might have on that stuff as well. So it's just a really fascinating topic that kind of is a practical application for our current lives, the study of evolution, and it's kind of an emerging field. So it's pretty exciting, and I will actually be looking into maybe a graduate certificate in that later on. But I definitely implore you to check it out, and hopefully you enjoyed my presentation.